To write a function in Mathematica, you use this syntax: f square brackets x underline or underscore and the square brackets colon equals, and then whatever the description is of the function. So for example, I could do x squared plus 1. And now if I do f square brackets 3, I get 3 squared plus 1, which is 10. So the two most important things to notice are this underline that comes after the x or after the variable name inside the square brackets. Notice that it doesn't show up on the right-hand side. It only shows up on the left-hand side. So that's the first important thing to notice, this underline. Second important thing to notice is this colon. So let me explain both of those, and let me start with the easier of the two to explain. What if I do gx colon equals x squared minus 7? So then let me do g bracket 3. So notice that nothing happened here. I didn't get 3 squared minus 7. And what's the problem? Well, here the way this is working inside of Mathematica is it's saying g square brackets x, that is defined to be this. So if I do g brackets y, nothing happens. But if I do g brackets x, then I get what I wanted. I get x squared minus 7. They've just written it in a different order, but I get the same function, x squared minus 7. And so what this little underline does is that's what's called a pattern inside of Mathematica. And it says anything, call it x, and then anytime I write x on the right-hand side, that corresponds to this variable. So for example, let me do another one. Say I do h, and then how about a underscore b underscore? And then I'm going to do colon equals 2 times b plus a. So now if I do h 3, 7 and evaluate it, so what's that like saying? It's like saying 3 is the a, 7 is the b, so it does 2 times 7 plus 3. So 2 times 7 is 14, plus 3 is 17, and that's where this comes from. So that's what the underline does. It's a pattern. It's saying, I don't care about it being called the letter A. That's just my abbreviation for saying what comes before the comma in this case. Okay, I could have called it x underscore y underscore, and then as long as I use the same letters, the y and the x over here on the right-hand side, then that also would have worked. So for example, if I had done j x underscore y underscore colon equals 2 times y plus x, that's going to work the exact same way. So if I do j 3, 7, I get the same thing. So that's how this underscore works. What about the colon? Well, that's a little harder for me to explain. I have to come up with a little more artificial of an example. So just as an example, say I do m bracket x underscore equals x squared. So here I've forgotten the colon. And so say I do m brackets 3. So it seems like that worked fine without the colon before the equals, without the delayed assignment part. But what about an example where it doesn't work? So let me try to redefine it, or let me define a new one. Let me do n x underscore equals the minimum of x. So here I'm not thinking of x as a number, I'm thinking of x as a list. And let me try it out and see if it works. And this is an example where it's not going to work. So let me do, as my input x, let me do 7, 2, 10. So that didn't work. I was hoping to get the output 2, but instead I got as output this entire thing. And what's the reason for that? Well, up here when I did my immediate assignment with the equals, that immediately evaluated what's the minimum of the symbol x. Okay, and the minimum just fell away and I was left with only x. So it's the exact same as if I had said n of x underscore equals x. So here it was like n of this list equals this list. So let me try it again, this time with a colon. And so now what that's saying is, don't try evaluating the right-hand side until I evaluate n again. So here I'm evaluating n again with my input as this little length 3 list, 7, 2, 10. And then when I evaluate it, it plugs in 7, 2, 10 for the x, takes the minimum, and that's why this output is 2.